Hello students, welcome to Narayan PU College online classes. So we are discussing about the P block, that one 15th group elements. So in the last video we have discussed about the dinitrogen, where that is N2, preparations, physical properties, chemical properties and uses. And the next concept is ammonia. What is the formula of ammonia, Mahia? Ammonia formula is NH3. Clear? So ammonia is present in air and soil, clear? Where it is formed by decay or decomposition of nitrogenous organic compounds or organic matter like urea. Clear? So it is ammonia is present in small quantities in air and soil. Clear? How they are present? Because decay of nitrogenous compounds are present in the soil and air, they decompose and gives here ammonia. Clear? So you know that urea, what is the formula of urea? NH2CO NH2. This is the urea, nitrogenous organic matter. It undergoes decomposition. You know, first it will react with the water, it will react with H2O, then it gives here 2 moles of H2O, 2 hydrogens will be added here and another 2 hydrogens will be added here. I have to take how many moles here? 2 moles. Total how many hydrogens are? 4. 2 hydrogens will be added to the NH2, means NH2 is become a NH4, and here 2 hydrogens will be added, so that's why shall I write this is NH4 twice, and here CO is there and 2 oxygens will be converted into CO3. Will be converted into what it is, no? CO3. Ammonium carbonate. Clear, no? What it is? Ammonium carbonate, and this is further decomposes. If you heat this, then what it will be? Decomposes and gives ammonia. Clear, no? NH3 is there, means NH4 is there, and you will get the 2 NH3 plus, you know, total 8 hydrogens are there, we used here 6 hydrogens. Clear, no? And CO3, when you heat, it gives the carbon dioxide gas plus, and 8 hydrogens are there and here 6 hydrogens, 2 hydrogens are there, 2 hydrogen in here, 1 oxygen left, and it will give H2O. This is clear, ma? So this is ammonia present in small quantities in air and soil, where it is formed by the decay of nitrogenous bases, nitrogenous matter like urea. Clear, ma? You are getting which one, ma? Ammonia. Clear? So now first we have to discuss about the preparations of ammonia. Clear, ma? Preparation methods. Preparation methods. Clear, ma? So how to prepare this? Clear? And first one is here, you know, in the laboratory. In laboratory, how we will prepare? In laboratory preparation. Laboratory preparation. Clear, ma? So in the laboratory, how we will prepare this ammonia? Clear? So in the laboratory, what we will do? We will heat the mixture of ammonium chloride. What it is, ma? Here ammonium chloride and calcium hydroxide, can also be called as slaked lime. Can also be called as which one, ma? Here slaked lime, and heat it. Clear? Then what you will get, you see, and calcium and chlorine will be removed as a calcium chloride, will be removed as a which one, ma? Calcium chloride. Clear, ma? Here now you know that, and here calcium chloride, how many chlorines are there here? 2 chlorines here, how many are there? 1, so that's why you have to multiply this one with the 1. So then 2 moles of ammonia, first I will write ammonia here, and CaCl2 will be removed, and then 2 moles of ammonia NH3. Clear, ma? Plus, you know, total 8 hydrogens are there, here 6 hydrogens, and here you know that 2 hydrogens are left here, and here 2 OHs are there, so 2H and 2OH, you will get the 2H2O. This is how in the laboratory and ammonia is prepared. Ammonium chloride, the mixture of ammonium chloride and calcium hydroxide can also be called as a slaked lime, and you will get the ammonia and calcium chloride, you will get the water. Clear, ma? Here now, and the second process, what is the second method? By heating ammonium salts, This is laboratory and this is normal methods. Clear? By heating by heating ammonium salts, by heating ammonium salts by strong bases. By which one here? Strong bases. This is the second process. Clear ma? By heating ammonium salts by strong bases. This is only the laboratory method. These are not laboratory methods. Clear ma? So now I will take here ammonium salts means I will take ammonium sulfate. What is the name of this compound? Ammonium sulfate, treated with the strong base like NaOH. Strong base like what it is? NaOH. Then you see what you will get here. Sodium sulfate will be removed because here sodium is there and sulfate is there. You will get the sodium sulfate Na2SO4. You know the sodium sulfate formula. Clear ma? Na2SO4, and you know that here 2 Na, so that's why I have to multiply this one with the 2, and here NH4 is there. You will get 2 moles of ammonia, and here 8 hydrogens are there, 2 hydrogens left here and 2 OHs are there. Then you will get the 2H2O. What you are preparing ma here? Ammonia gas. Clear? Ammonia is a gas. Clear? Next one. And same, if I take suppose ammonium chloride, take the ammonium chloride and treated this one with the KOH, potassium hydroxide. Ammonium chloride and potassium hydroxide, potassium and chlorine will be removed as a KCl, and NH3, 1H and 1OH will be removed as a H2O. Then which one will be left ma here? Ammonia. This is clear ma? So this is and second preparation. Clear ma? And now very important here, you see along with ammonia we are getting water also in this reaction. Clear ma? As a product, you know, ammonia is forming and also water. So you know that we have to dry this ammonia. Clear ma? So ammonia is very important point here in the competitive examination. It will come. Ammonia is dried. Ammonia gas. Clear? Ammonia is dried over quicklime. Quicklime. Over which one ma here? Quicklime. So you know that what is the formula of quicklime here? You know that CaO. This is the quicklime. Clear ma? So ammonium is dried over the quicklime. Clear? You know that ammonia is a base. We have already discussed in the previous physical properties. Clear ma? Basic nature of, you know, 15th group hydrides, and all 15th group hydrides are basic in nature. Why? Because they have lone pair of electron. They can donate the lone pair of electrons to other. So lone pair donor we will call as a Lewis base. So that's why being a ammonia, being a basic nature, being a basic gas, it cannot be dried over the dehydrating agents like, you know, concentrate H2SO4, concentrate H3PO4, phosphoric acid and calcium chloride. Clear ma? So ammonia, same here, being basic gas, cannot be dried over dehydrating agents like what it is ma? Like, you know, concentrate H2SO4 or concentrate H3PO4 or calcium chloride, etc. Why? You know that. And suppose if I take here ammonia gas, if I treated this one, it is, you know, ammonia gas having what it is ma? Water. Clear ma? So because when we prepared along with ammonia, water is also present. So this is, if I suppose use here concentrate H2SO4, you know, concentrate H2SO4 is a powerful dehydrating agent. Clear ma? So it can, water is present in ammonia can be removed this, because it is a dehydrating agent, but it cannot. Why? Means it is a base and it is a acid. What happened here? Reaction takes place. So that's why it cannot be used to dry ammonia. Clear? No? So that's why what you will get here? Ammonium sulfate. and it is reaction takes place. When reaction takes place, we cannot remove the water. Clear? In the same way, if I take suppose here ammonia and treated this one with the calcium chloride, and calcium chloride when it is treated with the ammonia, it will form a complex. Clear? What is the complex here is CaCl2 8NH3. This is the coordination complex. Clear? So this is, we have to take 8 molecules. Clear? In the same way, if I take suppose ammonia and to dry this, because I mentioned here ammonia means here water we want to remove. Suppose if I take ammonia, dry here moisture ammonia, then if I want here take the phosphoric acid to remove the water in the ammonia, then it cannot be. Why? Because it is a base and it is an acid, reaction takes place. Then what you will get here? You will get ammonium phosphate, PO4. Clear here? So that's why take the 3 moles here. So important point here, ammonia is dried over the quicklime, that is what it is here, calcium oxide. We should not use here sulfuric concentrate H2SO4 is 3PO4 CaCl2. These all are dehydrating agents. These dehydrating agents we cannot use to dry the ammonia. Why? Because ammonia will react with those dehydrating agents. Clear? So this is about the what is my first and second preparation. Next preparation of ammonia is by using Haber process. Large scale of ammonia is manufactured by using this. Your ammonia is synthesized by using this Haber process. Very, very, very important for your PU examination. Among these preparations, this is only will come in the PU examination. Clear? For 3 marks question. So they will ask here what is the preparation method and conditions, flow chart is there. Clear? And these 3, if you prepare perfectly, so many times this question they are asking in the PU examination. I said 3 questions will come for the 3 marks. So 90% of chances are there to ask this type of question. Here 3 processes are there: Haber process, next Oswald process, and contact process. Among these 3, 1 question will come in the PU for 3 marks. Clear? So that's why you have to be careful. Clear? So Haber process. Clear? So in the Haber process, ammonia is prepared by nitrogen gas, clear plus H2 gas. And whenever nitrogen gas and H2 gas is reacted together, and you will get the compound is ammonia. Clear? So balance here, how many hydrogens are there? 3 hydrogens. Here how many are there? 2. So that's why I will multiply this one with the 3 and I will multiply this one with the 2. Then what it is? 3 into 2 6 and 3 into 2 6. Hydrogens are balanced and nitrogens also what it is? Balanced. And this reaction is a exothermic reaction, 46.2 kilojoule per mole. Clear? So first point here, this is a reversible reaction. Reversible reaction. This is a which reaction here? Reversible reaction. Clear? And second one, this reaction is a forward reaction, is a exothermic reaction. Exothermic reaction. Exothermic reaction. Clear? So these are 2 points. But here conditions are there. Clear? So important conditions. Clear? So here these are very important, you have to write, because to get both are gases here, nitrogen gas and here also hydrogen gas. Hydrogen and gases to react each other, we have to maintain the drastic conditions. Easily they won't react easily. You have to increase the high pressure and you have to maintain the high temperature. Then the gases will come, when pressure high, the gases will come very close to each other and then reaction starts. Clear? So that's why to get a good yield or more amount of the ammonia, so which conditions you have to maintain, that we have to discuss here. Clear? The first one is temperature. So what is the temperature to maintain here? How much temperature to maintain to get a very good yield of ammonia here? So first one, that this is a forward reaction, is a exothermic reaction. So you have studied already in the first year, Le Chatelier's principle. Clear? So in that one, whenever the forward reaction is a exothermic reaction, then low temperatures are favorable for that reaction. Clear ma? So the forward reaction is favorable at low temperatures. Clear ma? And if we maintain, experimentally it is determined, if we maintain the low temperatures here for this reaction, and we are getting very less amount of NH3, yield of NH3 is very, very less. So that's why what is the optimum temperature for this reaction is 700 Kelvin. This is the optimum temperature. Clear ma? Then next one is pressure. Next one is how much pressure you have to maintain to get a high yield of this NH3. Clear ma? So next pressure here is, that, and since the forward reaction, here how many moles are there ma this side? Total moles of reactants here 4, 1 plus 3, here 4. Reactant side how many moles are there? 4. And product side how many moles are there? 2. So that's why here volume is moles more, means volume will be high, and reactant side volume will be less. That since the forward reaction is occurs with decreasing in the volume, according to the Le-Chatelier principle, you have to apply high pressure. Clear ma? So what is that pressure? How much pressure you have to apply is 200 atmosphere, or you can write here 200 into 10 power 5 Pascal. Clear ma? 1 atmosphere is equal to 10 power 5 Pascal, but you have to write 200 atmosphere. Clear ma? And also, even though you are maintaining this high temperature and high pressure, the reaction is not that much fast. So that's why to make a reaction very fast, we will use the catalyst also. We will use the which one here? Catalyst. What is the catalyst here is iron oxide. What it is here? Iron oxide plus along with this small quantity of K2O plus Al2O3 also will be used. Clear ma? So this is catalyst. And next one is promoter. Promoter. Clear ma? Promoter here is molybdenum. What it is here? Molybdenum. So what the promoter? Promoter, it is a co-catalyst. It increases the activity of, catalyst. And these are the main conditions to maintain for which one here? To get a good yield of Haber process. Clear? Sometimes what they will ask, and here explain the Haber process and write the conditions to increase to get the more yield of ammonia. Then what you have to write ma? You have to write reaction, and here first one is it is the reversible reaction, exothermic conditions. Temperature should be, optimum temperature should be how much ma? 700 Kelvin, and pressure will be 200. And catalyst, what is the catalyst you have to write here? Catalyst is a iron oxide. Clear ma? And along with that small quantities of potassium monoxide and alumina, Al2O3. And promoter, or you can write co-catalyst is here molybdenum. Clear ma? So this is about the preparation. So this is flow chart of Haber process. So this is what we have discussed up to conditions for the Haber process. Now this is the flow chart. Clear ma? See, now this is important. Why? Because in the examination also they will ask, they will ask, explain the Haber process by drawing the flow chart also. Like that they may ask the question. Clear? You see here, this is the flow chart of Haber process, preparation of ammonia, and from here we will pass the hydrogen and nitrogen gas, and this hydrogen and nitrogen gas is passed into the compressor. Because these are gases, these are gases, so that's why. And here compressor means we will apply the pressure, then the gas molecule will come close to each other. When they come close to each other, they try to react, and then after then we will send and these gases to this another chamber. Their catalyst is there, iron oxide, K2 and Al2O3, and also we maintain how much temperature here? 700 Kelvin temperature. When we maintain this temperature, then nitrogen and hydrogen will react and gives the which one? Ammonia. So that's why here some of the nitrogen and hydrogen gas will be converted into ammonia, and some unreacted nitrogen and hydrogen also will be present. And both means here hydrogen and nitrogen react and gives the ammonia. Some unreal 100% reaction may not take place, so that's why some unreacted nitrogen gas and hydrogen gas also will come, and here it will be cooled down, then liquid ammonia will be formed. Clear here? So we will collect here liquid ammonia, and you know that this unreacted N2 and H2 again passed here through the pump into again catalyst, means in the catalyst chamber. So that's why again at these conditions, iron oxide catalyst and 700 Kelvin temperature, again this nitrogen and hydrogen will react and gives the sum of ammonia. And ammonia is here you will get liquid ammonia. Again some unreacted one, again we pump to the catalyst chamber, so again it will react, and some unreacted N2H2 again converted into NH3. So we will keep on doing this one till total N2 and H2 converted into ammonia. Clear ma? So this is about the which one ma here, this is the flow chart of what it is ma here, preparation of ammonia. Clear ma? So this is Haber process with preparation and here flow chart. Clear ma? Pass out. Clear? And next one is preparation method by hydrolysis of metal nitrides. This we have already discussed, metal nitrides. Clear? So in the preparation of 15th group hydrides we have discussed this method. Clear? So take here metal nitride, I will take here magnesium nitride, Mg3N2. You know how to write this formula, because you know that magnesium, what is the valency of magnesium here? 2, nitrogen valency is 3. Do the crisscross method, then what you will get? Mg3N2, that is only. This is what the name of this compound? This is magnesium nitride. Magnesium, what it is here? Nitride. Clear? So magnesium hydride, hydrolysis means what you have to do? Add water. Clear? So then what you will get? You will get the compound is magnesium hydroxide plus ammonia. Magnesium hydroxide plus what it is? Ammonia. Previous we have already discussed. See, now balance the equation. How many magnesiums are there? 3. So that's why I put here 3 magnesiums. Clear? Then how many hydrogens are there? 2 into 3, 6. And here nitrogens, how many are there? 2. So multiply this nitrogen with the 2. So magnesiums and nitrogens are balanced here. So you have to balance the oxygen and hydrogens. So how many oxygens are there? How many hydrogens are there here? 2 into 3, 6, and 2 into 3, 6. Total how many? 12. 12 means I have to put here 6 hydrogen. 6 H2 mark. So this is another method of what it is, preparation of ammonia. And next method, clear? By heating ammonium salts. By heating ammonium salts. Clear? So this is another method. Clear? So ammonium salts means take here ammonium salts. You can take ammonium sulfate. Clear? Ammonium dihydrogen phosphate, and those salts if you heat, then you will get the automatically ammonia gas will be liberated. See the example here. The first one, ammonium sulfate. Ammonium means what you have to write? Ammonia means NH3. Ammonium means NH4. Clear? Ammonium sulfate. Take the ammonium sulfate and heat it. Clear? Then what you will get? Ammonia gas will be released here. So what is the ammonia gas here? NH3. Clear? And next one, NH4. What is there here? NH4 and H, because how many hydrogens are there here? Total 8 hydrogens. I have written here 3 hydrogens and here 4. 3 plus 4, 7. So that's why HSO4. This is SO4 is left. So NH3, 2 NH4s are there. So one I have written as a NH3 and another one I have written as a NH4. And here one H will be there. That H here and SO4 here. So this is ammonium bisulfate, or you can write hydrogen sulfate. Clear ma? Hydrogen sulfate. Clear? So what gas you are getting here? We are getting here ammonia. So in the same way, take the another salt, ammonium, NH4 and H2. Don't put a dot here. NH4, H2, PO4. What is the name of this compound? Ammonium. NH4 means what you have to write? Yes, you have to say ammonium dihydrogen phosphate. That is, write the name here. Ammonium dihydrogen phosphate. Clear ma? Dihydrogen phosphate. Same, just heat it. Just I mentioned here, heating, you see, by heating ammonium salts. So if you heat here, you will get NH3. Clear ma? One of the NH4 will be converted into NH3. Now you see, in this case, one oxygen and hydrogen. See here, one hydrogen, here one hydrogen, two hydrogens, here one oxygen will be removed as a water. Got my point here? One oxygen here, two hydrogens means here NH3 I have written, one hydrogen left here and here one hydrogen is there. These two hydrogens, one oxygen will be removed as a H2O. Then what is left here? HPO3, that you have to write. That is what it is here, HPO3. What is the name of HPO3? Metaphosphoric acid. Metaphosphoric acid. Clear ma? So this is. So same here, another one we have to take, very important, this is for competitive, microcosmic phosphate. Clear? So what is that one here is Na, NH4 and HPO4. This is and 4 H2O molecules. So one time that this question they have asked in the competitive. So what is the microcosmic salt? Microcosmic salt. This we will call as what it is, microcosmic salt. So they have given. So which one is the microcosmic salt? 4 options they have given. So this is the one. This is also what it is, salt only, ammonium salt, because NH4 is there, ammonium salt, and just heat it this one. What you will get? Same method. See, NH4 is there and it will be removed as a NH3 gas here plus. Clear ma? Next one. Here one hydrogen, here one hydrogen. Two hydrogens, one oxygen will be removed as a water. Then what is left you see? See, 3 hydrogens we have written and here total 5 hydrogens are there. 3 I have written and 2 I have used here. Totally 5. So no hydrogen left here. Then what is there? Sodium and PO3 is there. That we will call as a NaPO3. See ma? So HPO3, now what it is? NaPO3. What is this is? Sodium metaphosphate. Salt it is. Clear ma? Sodium metaphosphate. Clear? So this is another method for the preparation of which one ma? Ammonia. And next one, 6th one. You know that by hydrolysis of clear ma here? Sodium calcium cyanamide. What is the name of this one? Calcium cyanamide. Names important. Clear? So now do this one hydrolysis. So I have mentioned already this one. When we have properties, chemical properties of dinitrogen. So prepare, you know that dinitrogen reaction with carbon calcium carbide and you will get the calcium cyanamide. And do this one, take the CaCN2 and treat this one with one. Hydrolysis means what you have to do? Treat this one with the water. Then you know that ammonia gas will be released here. Which gas will be released here? Ammonia gas. Clear? See now. And here how many hydrogens are there? 3 hydrogens. But here how many hydrogens are there? 2. So balance here. I will multiply this one with the 3 and I will multiply this one with the 2. Then here 6 hydrogens, 6 hydrogens. Hydrogens are balanced. And next one, what is there here? You see 2 nitrogens are there. Here also 2 nitrogens. 6 hydrogens, 6 hydrogens. Remaining what left here? CaC and oxygens. What is the CaC? How many oxygens left here? 3. So that's why calcium carbonate. So this is what it is here. Preparation. All these are preparations of ammonia, but in the NCERT textbook first 3 preparations only they have given, and these are will be used for the competitive examination. This is very important. Cosmic, microcosmic salt. So next one is structure of ammonia. Clear ma? So you already know that nitrogen. What is the nitrogen valency electronic configuration? We can write 2s2 2p3. Clear ma? 2s2 2p3 means here 2 electrons are there in the s orbital and 3 electrons are there in the p orbitals. Clear ma? So that's why, and these unpaired electrons will only participate in the bond formation. So that's why nitrogen will form how many bonds ma? 3 bonds, and 1 lone pair is left here. Clear ma? So that's why if I write here hybridization of the nitrogen central atom in NH3, how to calculate the hybridization? I already mentioned here one trick to calculate the hybridization. Number of sigma bonds plus what it is the formula, and number of free lone pairs. This is the simple trick to calculate the hybridization. You know nitrogen forms how many bonds here? 3 hydrogens means 3 bonds, and here 3 and plus, and number of free lone pairs. How many lone pairs are there? This one lone pair is there. So that's why 3 plus 1 how much ma? 4. 4 means what is the hybridization? sp3. So the central atom nitrogen hybridization. Clear ma? This I will rub because you already know. Clear? So nitrogen, that is central atom nitrogen hybridization in NH3 is what it is ma here? sp3. Clear? You know that. How many bond pairs are there here? Bond pairs, there are 3 bond pairs and plus 1 lone pair. And you know that whenever there are 3 bond pairs and 1 lone pair, what is the structure of the molecule? The structure of the molecule is pyramidal structure. The shape of the molecule is which one ma? Pyramidal structure. You know that. What is the pyramidal structure? Clear ma? So you know nitrogen, and it is making bond, and here there will be a bond, and hydrogen there will be a 1 lone pair of electron. This is what we will call pyramidal structure. You know what is the bond angle here? 107.8, or simply this is bond angle. What is this bond angle ma here? 107.8 degree, or sometimes 5 also they have in some textbook they mentioned 5, but this is the bond angle. So this is about the what it is ma? Structure of the molecule. And next one is physical properties. So same we have discussed for the dinitrogen. First one is preparation, then physical property, but here structure has come. Physical properties. Clear no? We have 4 or 5 physical properties. We will discuss one by one. Clear no? So you know that nitrogen is a source, ammonia is a clear. It is a colorless gas. I already mentioned ammonia in the previous preparation. Also I mentioned, I used it to mention there ammonia gas. Clear? So ammonia, it is a colorless gas with pungent smell like ammonical smell. If you see ammonia bottle, if you have already done practical in the laboratory, and ammonium hydroxide, when you open the lid of that bottle, you might have observed the smell. Clear? That smell we can call as a ammonical smell. Clear? No? So that's why ammonia, NH3 is a colorless gas with pungent smell. Like which smell ma? It is pungent smell like ammonical smell. Clear? This is the first point. And the second point, ammonia is lighter than air. As compared to ammonia is lighter weight compared to the air. So that's why that is the second point, is it is lighter than air. What it is here? Air. And the third one, if you see, it is highly soluble in water. I already mentioned previous when we discussed about the solubility of and 15th group hydrides. Ammonia is highly soluble in water. Why? Because you know that ammonia only can form the hydrogen bonds with the water molecule. So which molecule can easily form the hydrogen bond with water? And that molecule can easily soluble in water. So that's why it is highly soluble highly soluble in water. So that's why we cannot, collect the ammonia over the water. We cannot collect. Why? Because it will be dissolved. Clear? So next point. It has, I already mentioned, it has, ammonia has higher melting and boiling point compared to the hydrates of the remaining 15th group elements. Clear? Why? We have already discussed, because ammonia can form the intermolecular hydrogen bonding. So that's why, and it has high melting and what it is here, boiling points than expected. Clear? Why? Because of, or due to intermolecular hydrogen bonding. These are the, what it is here, physical properties. How many are there? 4. Mainly NH3, it is a colorless gas with pungent smell. That pungent smell, it is, ammonical smell, and it is a lighter than air. So that's why it is flow over the, means if you take the air and ammonia, which gas easily escape? Ammonia gas can easily escape. And highly soluble. Why highly soluble? Because ammonia can make a hydrogen bonds with the water molecule, and it has high boiling point and melting point than expected. We expected, and previous when we have discussed about the hydrates of 15th group, and NH3 should have the lowest melting and boiling point than the hydrates of 15th group, but it is having high melting and boiling points. That is expected, because of intramolecular hydrogen bonding is existed among the ammonia molecules. Clear? So we have completed preparation methods and the structure of ammonia, and also physical properties, and next coming to the chemical properties. Clear? No? So first chemical properties here is basic nature. Clear? You know that ammonia is a Lewis base. It can donate the pair of electron, and also I mentioned just now only, ammonia is highly soluble in water. Just now I mentioned in the physical properties, because it can make a hydrogen bonds with the water molecule. Clear? No? So that's why ammonia is highly soluble. Its aqueous solution, if you take aqueous solution of ammonia is basic. Ammonia is what it is here, basic, because of OH minus ions present in the solution. Clear? Simple. You see, write the reaction here. Ammonia, this is ammonia gas, and dissolve the ammonia gas in water, H2O. Clear? Then what the compound you will get? You see, this is a reversible reaction. Clear? See now, NH3 and H2O, what you will get here, NH4OH. Clear? Just add, 3 hydrogens are there here, and 1 hydrogen you add, then you will get the ammonia is converted to ammonium, NH4. Clear? And 1 OH, and H and OH left here. That is, what is the name of this one? Ammonium hydroxide. What is this one, ma? Ammonium hydroxide. Clear? Now it easily undergo dissociation. Clear? Because it is a weak base. So that's why you will get, whenever it dissociated into, NH4 plus OH minus. Clear? You have already know how to dissociate this molecule. NH4 plus, because here what it is, NH4 and OH, like if I write nitrogen and oxygen, which is more electronegative? Oxygen is more electronegative than nitrogen. So that's why this bond pair electron will shift towards the oxygen. Oxygen is gaining electron. Gaining electron means acquires negative charge. Nitrogen is losing electron, acquires with charge, positive charge. That is clear, no? So if you see in this solution, which ions are present here? OH minus ions are present, H plus ions are present, acid, OH minus ion present, base. So that's why the aqueous solution of ammonia is a basic, because of which ions here? OH minus ions. Clear, no? This is the first one. And second one is reaction with metal salts. Reaction with what it is here? Metal salts. always nitrogen is highly soluble in water, so that's why nitrogen always ammonia, sorry, not nitrogen, ammonia is highly soluble in water, so that's why almost always it is existed in the ammonium hydroxide. Solution is there, you see in the laboratory we have done so many experiments with the ammonium hydroxide. What is meant by ammonium hydroxide? Because ammonia is a gas, so we have to pass the gas into the water, then it will be converted into solution. That solution we will called as a ammonium hydroxide. You know ammonia easily soluble, so that's why we sometimes we will write ammonia, or sometimes we will write ammonium hydroxide. Hydroxide means solution of ammonia. Solution of which one? Ammonia, that you remember. So reaction with metal salts. Now metal salts will react with the ammonium or ammonium hydroxide solution, ammonia solution. If I say ammonia solution, then you have to write the ammonium hydroxide. Clear? So like metals, you know, FeCl3 and treated with the ammonia solution, that is what it is, aqueous. Ammonia solution means ammonia gas is passed through water, you will get ammonium hydroxide, and then these metals are precipitated into respective hydroxides. Clear? You know that here which one is there? Cl is there, and here which one is there? OH, and OH replaces the all the chlorine atoms. Then how many chlorine atoms are there? 3. So here 3 OH's groups replaces the 3 Cl groups. Then I have to multiply this one with the 3. Then only I will get 3 OHs, and these all Cls are replaced by OH. Then what you will get here? FeOH thrice plus 3 chlorine atoms are removed here, and here 3 NH4s are there. So you will get NH4Cl, ammonium chloride. Clear? So this is, and you know it is a brown precipitate. It is a which one, ma? Brown precipitate. Clear? So this is, and how this is a reaction with the metal salts. And you know, take aluminum also, AlCl3, same reaction. You know, 3 moles of ammonia water, clear, ma? Or aqueous ammonia. Then what you will get? AlOH thrice plus 3 moles of ammonium chloride. These all are which one, ma? Precipitates. Brown precipitate, and it is a white gelatinous precipitate. Clear? And next one, if you take chromium, CrCl3 also, same reaction, NH4Cl, and then you will get the chromium hydroxide. It will be precipitated as a chromium hydroxide, and you will get the, clear, no? So NH4OH, then you will get NH4Cl. What is the why I am saying here, these colors are important. Precipitate, clear? Here brown precipitate and white precipitate, and you will get here green precipitate. Green precipitate. You know, you have already done salt analysis in the first year, and third group, these all are third group cations, and third group cations are identified by adding the ammonium hydroxide. Clear, no? And also not only this, take the zinc sulfate or zinc chloride you take, clear, ma? And treated this one with the ammonium sulfate also you can take. Every time you are taking chlorides here, take the sulfate. Then what you will get, ma? You will treated this one with the aqueous ammonia. Then you will get the compound here is ZnOH twice, zinc hydroxide. It is a precipitate. Which precipitate here? White PPT. It is what it is, ma? White PPT, and you will get the ammonium sulfate. Ammonium sulfate means what it is, ma? NH4 twice SO4. So you have to take how many moles here? 2 moles. Clear, ma? So in the same way, copper sulfate you take CuSO4 plus 2 moles of ammonium hydroxide. Then what you will get, ma? You will get the copper hydroxide. What is the copper hydroxide color here? Blue precipitate, and it will be converted into same again ammonium sulfate. Clear, no? So these are, you know what it is, ma? Here reaction of ammonia or ammonia solution with metal salts, and this is the second one. And the third one, clear, ma? And formation of complex compounds. Formation of complex compounds. Complex compounds, or you can say coordination, formation of complex compounds. Clear? So this is formation of complex compounds. So in this one, you know that I already mentioned ammonia is a Lewis base. It has one lone pair of electron on his head, so it can donate the pair of electrons to others. So that character we will call as a Lewis base character. Clear? It can donate pair of electrons to electron deficient compounds or the ions having the empty d orbital. If anyone is having empty d orbital, it donates pair of electrons and make a coordinate bond. Clear? And that and by forming the what it is here, complex compounds. So simple example, I will take here Ag plus metal and treat this one with the ammonia gas. Clear? Then what you will get here is, and take the 2 moles here, then you will get AgNH3 twice and plus. Here charge is plus here. This is complex. Clear? If you wanted to write here in the form of compound, instead of Ag plus, take AgCl. Means what is Ag plus? Now I am taking compound here, Ag plus and Cl minus, and treat this one with the ammonium hydroxide solution now. Clear here? Then what the compound you will get? Take the 2 moles here, then you will get the compound is, it is a white precipitate. It will be dissolved in the ammonium hydroxide solution. Ammonium chloride is a white precipitate and it is dissolved in the ammonium hydroxide and make a complex. What the complex you will get? You see, you will get the same AgNH3 and 2 times, and clear what it is, Cl. Previous you see there is no Cl, so that's why I mentioned simply plus, and here AgCl is there and plus, and water molecule will be removed, and 2 into hydrogens how many are there? 6, but here 8 and here 1 9, so that's why you get here is H2O, water molecule will be removed. Clear here? So 6 and here 4 and here 1 hydrogen is there, and you will get the H2O. In the same way, if I take, suppose this is the first one, if I take here copper means what is copper plus 2 plus and NH3, you will get the compound here CuNH3, how many times here? 4 times, and get here plus 2. This is ion reaction with the what is ion. If I take here in the form of compound, then it will be which precipitate here? Blue PPT, and this will be dissolved in ammonium hydroxide. Take here 4 moles here, then 2 moles means 2 H2O you will get. Clear? 2 oxygens are there, so that's why you will get the compound is here CuNH3, how many times here? 4 times, and SO4 is there here, so you have to write SO4, and the next 4 oxygens are there, so that's why, and oxygens will be removed as a water. Clear? So this is about the formation of complex compounds. Next one is here oxidation. Clear? So ammonia undergo oxidation, or ammonia oxidized to nitrogen with the metal oxides, with the what it is here? Metal oxide. See the reaction. So what is this one? Take the ammonia and treated this one with the copper oxide. So oxidation, it get ammonia get oxidized to which one? Nitrogen, and here hydrogen and oxygen will be removed as a H2O, and plus here copper is there, and copper will be converted into Cu. Clear? So you know that what is the oxidation number here? -3, and here what it is? 0. Clear? So copper is a oxidizing agent. It oxidizes the ammonia into nitrogen. So what is the oxidation state? -3, here 0. Oxidation state increases means it get oxidized, and it is oxidizing agent. Oxidizing agent oxidizes other compounds and itself it undergo reduction. Oxidizing agent undergo reduction. So it is what it is? +2, and here what it is? 0. So it is a reduction. Oxidizing agent undergoes reduction. Clear? So now balance here, how many hydrogens are there? Just for understanding purpose this is. Okay. So this is 3 nitro hydrogens are there, and here 2. So I will multiply this one with the 3, and I will multiply this one with the 2. So now 2 nitrogens are there, here also 2 nitrogens. Oxygens are 3, and I have to multiply this one with the 3, and here multiply this copper also. 3 copper atoms are there, multiply this one with the 3. Clear, Matis? Next. And in the same way, not only copper, and take the lead oxide, it is also metal oxide, same, it will be oxidized to nitrogen, and you will get the 3 moles of Pb and 3 moles of H2. Clear? And the next one, fifth one, reaction with halogens. What it is here? Reaction with halogens. Very important, this is reaction with halogens. In this one, first one is reaction with chlorine. Reaction with which one here? Chlorine, Cl2. So this is very, very important for your PU examination. Clear? So they are asking most of the time this question only. Means for one is there, complete the following equations, there it will come. Clear? So first one is ammonia plus Cl2. Clear? And here the product depends upon the amount of NH3 and Cl2. If you take excess amount of ammonia, take the ammonia excess amount compared to the chlorine, then you will get the compound is N2 plus NH4Cl. This is the compound. Clear? So you have to balance this. How many hydrogens are there here? 3, and here 4. I will multiply this one with the 4 and I will multiply this one with the 3. Clear? Then you see, and here nitrogens, how many this side? You see nitrogens are not balanced. Nitrogen 2 and here nitrogens 3. Total 5 nitrogens are there, here 4. So what I will do, I will make this one even number. I will multiply this one with the 2. Then what I will get here? 6. When I get 6 nitrogen and 2 nitrogens, total 8 nitrogens. 8 nitrogen means I will take here 8. Then how many chlorine atoms are there here? 6. 6 means here I have to take 3. This is clear? Whenever ammonia excess you take with the chlorine, you will get nitrogen gas and ammonium chloride. And in the same way, if I take suppose NH3 and Cl2, now if I take excess amount is Cl2, then you will get the compound is NCl3 plus HCl, nitrogen trichloride. Clear? So here balance atoms here. So how many hydrogens are there? 3. So I will multiply this one with the 3. So how many chlorine atoms are there here? 3, and here 3, 6. 6 means I will multiply this one with the 2. So this is very, very, very important. It is asking in the PU examination. Clear? So next one is, in that one, second one, reaction with bromine. Reaction with chlorine is over. Reaction with bromine. Bromine will react with the ammonia and gives N2 and 6 NH4Cl. Same reaction. Take here ammonia, and if you take excess whatever it may be, you will get the same product. Br2, you will get the compound is N2 plus NH4Br. N2 plus what it is ma? And same balancing, same what I have done, same. And 8, 3, and here 6. And third one, iodine is also there. Reaction with what it is ma here? Reaction with iodine. Clear? So reaction with iodine. Whenever it react with iodine, clear? These are not that much important, but this is very, very important. These are for competitive. So you will get NH3 when it is treated with iodine. You will get the compound is NH3Ni3 plus Hi. NH3 Ni3 plus what it is ma? Hi. So NH3 and Ni3 we will called as nitrogen triiodide ammoniate. Clear ma? This is a brown precipitate. It is which precipitate ma here? Brown PBT. Very, very unstable. Again it dissociated into nitrogen and iodine. Clear ma? Nitrogen and iodine, it will be removed. Clear? So this is reaction with what it is ma here? Halogens. And the next one, fourth, fifth and sixth one. Sixth one is here reaction with carbon dioxide. Reaction with which one ma here? Carbon dioxide. Clear? So whenever ammonia reacted with carbon dioxide, you will get the product is urea. What is the product ma here? Urea. Ammonia reacted with carbon dioxide and gives urea. Clear ma? So take here ammonia and treated this one with the carbon dioxide. You know, both are gases only. Gases means you have to maintain high temperature and pressure, so you have to maintain 453 to 473 Kelvin and maintain here 220 atmosphere. And first what you will get the compound is here ammonium carbamate. You will get NH4. What you will call here ammonium. This is ammonium. This is 220 atmosphere. Ammonium carbamate. Clear? This ammonium carbamate, you know, dissociate and gives urea. NH2CO NH2. What you will get here? NH2CO NH2. So NH2CO NH2 plus what you will get here? Water molecule, you see one oxygen and two hydrogens are left here. You will get H2O, and this is the what it is here urea. This compound we will called as a urea. So when ammonia is reacted with carbon dioxide, you will get urea.